Good morning. My name is John Ostlund. I will be your professor for the Introduction to Python Z1 section in Mini 1 of 2024. I'd like to get started by taking a look at the syllabus for the course. So let's go ahead and do that. Okay, so as I said, welcome to Intro to Python in Mini 1 of 2024. I am this guy, John Ostlund, and you can reach me by email either at my Carnegie Mellon email address or at my personal email address. I will be available to you 7 days a week from around 10 in the morning till around 9 in the evening. Sometimes I'm available before 10, sometimes available after 9, but 10 to 9 is my usual intention for being available. Now, when I'm teaching, I do work 7 days a week. I usually have office hours on the weekend as well as teaching during the week, so never hesitate to send me an email on a Friday night or Saturday or Sunday. I will see it and I will get back to you as soon as I can, almost always within 24 hours or less. We will have office hours for this course by Zoom every Sunday from 4 p.m. to 6 p.m. And you can click on the Zoom button over on the left side there to gain access to the links for those meetings. The final exam for this course will occur on Friday, October 11, and of course that will be an online exam since this is a remote course. I have a couple of good TAs who will be assisting me with the course. Mostly they will be responsible for grading homework assignments. You can also feel free to send them questions by email if you would like. And they may or may not hold their own Zoom office hours. I leave it up to them to decide whether they want to do that. All right. So this course has no prerequisites. We assume that you would like to learn how to do programming in Python, but you may have little to no prior programming experience. Okay, so we will look at the fundamentals of computer programming using Python 3, specifically Python 3.12 programming language. All right? We will investigate how to do what's called top-down procedural programming. We're going to take a look at how to construct admittedly relatively small software applications. We will have weekly homework. We'll have weekly quizzes. And at the conclusion, we'll have a final exam to test how well you have absorbed the material. We will look just a tiny bit at object-oriented programming in this course. Object-oriented programming is a sophisticated enough topic that we're not really going to have time to get into it in much depth in a seven-week course. All right. So as far as software, we'll be using something called the Anaconda package, version 2024.06. And if you look at my first announcement, which will be a welcome message, that announcement will contain a video that shows how to go about downloading and installing this Anaconda version 2024.06. Anaconda is a big package that includes not only Python itself, but also a bunch of editors and libraries and other things that are very useful for doing Python programming. There is online documentation at docs.python.org that you're welcome to look at. That can sometimes be pretty dense and terse if you are, relatively new to programming. I do have a recommended textbook if you feel like buying a textbook, starting out with Python by this fellow named Tony Gaddis. It's possible that there's a more recent edition out than the 5th edition. I honestly haven't checked. But anything from the 5th edition or later will be good to have. Now, this thing is expensive and not required. If you want to have a book to look at, this is a good book to have. Possibly you can find an edition that's older than the most recent one that you can get used for not too much money. A brand new one, as I recall, is around $120, which seems like robbery, but there you go. There's another very good but relatively advanced book called Python for Data Analysis, 3rd edition, and this is available for free through the Carnegie Mellon University Library. You can access it online. There's another book that a lot of people like. It seems kind of haphazardly organized to me, but a lot of people do like this book, called Automate the Boring Stuff with Python. And this has the very great advantage of being available completely for free on the web. So if you do a Google search for Automate the Boring Stuff with Python, you'll be able to locate this book online. Okay, so as I mentioned, in terms of evaluation, 20% of your course grade will be based on your performance on homework. 35% will be on quizzes, and the final 45% will be based on the final exam. Now, I think that homework assignments, I think that learning any language, whether it's a human language or a programming language, is much more efficient if you have someone to discuss things with. And so when we do homework assignments, what I'm going to do, come here. What I'm going to do is to assign everyone into teams of 2 people, possibly 3 people if we have an odd number of students for one of the teams. And you and your teammate will be required to submit the finished homework assignment together. Okay? Now, to get the most from any homework assignment, what you want to do is do as much of the homework yourself as you possibly can. And it's very likely that you yourself will be able to finish the homework. But then, I want you to compare what you've done with what your teammate did, and between yourself and your teammate, you can decide which version of the homework solution you want to submit. Only one team member should actually do the submission, and then both members of the team, or all 3 members of the team, will receive the same score for the submission. All right, so you might decide to submit one teammate's homework or the other teammate's homework, or you might decide after discussion to create some kind of revised homework to submit. In order to get an A on a homework assignment, you have to score 90 points out of 100. And because we have people working in teams, and because you are actually free to discuss these homeworks with anybody that you want to, including previous teammates and including me and the TAs, we pretty much expect that everybody will get an A on each homework assignment if you do the work and submit something that makes sense. Now, each week there are also some labs available, and you can just try these yourself. We don't grade the labs. We publish the labs and the solutions to the labs at the same time. So these are intended for practice and experimentation. Each week will be a quiz, which is online on Canvas, and which requires you to use what's called Lockdown Browser and Respondus Monitor. Lockdown Browser will prevent you from accessing any other software while the quiz is running, and Respondus Monitor will activate your laptop camera so that we can be sure that you don't have reference materials and somebody sitting behind you giving you the answers and stuff like that. All right. All right. So the quizzes are closed book, closed notes, closed web, individual. You should be sitting in a quiet place by yourself. And you want to make sure that you have very good web access when you do one of the quizzes. If you're in a place with poor web access and your quiz dies in the middle, that's that's pretty unfortunate. If that happens, you can usually physically turn off your machine and reboot and reconnect to the quiz, but that's not guaranteed. You will have 5 opportunities to get an A on each quiz. By A, we mean that you have to score on each quiz 87.5% or better of the available points. Different quizzes have different numbers of questions, which is why we're specifying that you have to get a certain percentage or better to get an A. You'll have 5 chances for each one. The questions are generated from a large question base. So if you take a quiz and score, let's say, 80%, if you take that quiz again, for that week again, it is vanishingly unlikely that you'll get the same questions the second time. All right? So it is very wise, if you don't pass a quiz, if you don't get an A on a quiz, do some reviewing of the material before your next attempt, and then try again. If you take this seriously and do studying in between attempts, 5 attempts should be plenty to enable you to get an A. Sometimes people will make the mistake of thinking, well, I know this stuff pretty well, so I'm just going to take the quiz 5 times in a row and hope that I get 87.5% or better on one of my attempts. This is a doomed strategy, all right? And usually people who try that, just burn through their available chances, falling short of an A. And then tough luck. We're not going to be willing to give you more chances if you burn through the 5 that you're allotted. Now, at the end of the course will be a final exam, which is going to be like a very long quiz. This will be available on Friday, October 11th. The last day of the last week of the course. And the quiz will be available for you during a 24-hour period. You have to, decide when you're going to take the final during that 24-hour period. Unlike the quizzes, you will only have a single chance to take the final exam. So do be careful to review everything carefully before you launch into the final. Now, only the final is only on the final is it possible for you to score an A+. Since the homeworks are collaborative, we fully expect everybody to get an A. And since the quizzes, you have multiple attempts to take, we fully expect people who take that seriously to be able to get A's on all of the quizzes. So we don't offer any A+. On the final exam, if you are one of the very top performers, you will get an A+, okay? And then, of course, lower grades for people who perform less well. Now, here are the so-called QPA or GPA points that Hinds College provides or specifies for different grade levels. And in order to figure out what your course grade is, we convert all of your homework and quiz and final exam letter grades into these points, and then we compute a weighted average. So 20% of your course grade will be based on your homework performance. Let's assume you get an A on all of those. 35% will be based on your quizzes. Let's again assume you get an A on all of those. Now, if you, for example, get an A-, if your final exam grade is an A-, then 45% of your score is based on that A-, which is worth 3.67%. When you compute this out, your weighted average GPA, or what CMU calls a QPA, is going to be 3.8515. Now, I compute course grades by setting a threshold midway between 3.67 and 4.00. So if your weighted average score is above the midpoint between 4.00 and 3.67, I round that up to an A. And this value, 3.8515, is above the midpoint between an A and an A-, so this would end up giving you a letter grade of an A for the course. All right. So what does that imply about an A+? Well, in order to get an A+ for the course, you have to get an A+ on the final exam, and all of your other homework grades and quiz grades need to be good enough so that this weighted average GPA that you get is strictly greater than 4. All right. So if you get an A+ on the final exam, and you get A's on all your homework, and you get A's on most, if not all, of your quizzes, then this weighted average may turn out to be greater than 4, and in that case, you'll get an A+ for the course. All right. So in terms of learning objectives, we're going to take a look at various so-called integrated development environments, or IDEs. I'm specifically going to talk about Spider, which comes with Anaconda, which is very popular. I'm also going to, for my lectures, I'm going to use this ancient thing called IDLE that Python provides. IDLE is a very simple, very plain integrated development environment. I do not recommend it for you. I like to use it for lectures because it is so plain. So when I show you an IDLE screen, there's going to be very little distraction on the screen. There's not a whole lot of buttons, not a whole lot of icons, not a whole lot of slider bars and sub windows and stuff like that. All right. So I recommend that you use Spider, whereas I will be using IDLE. Now, there's also a free integrated development environment that a lot of people like called PyCharm that you can download and use if you prefer. People who like it say it's a little bit better than Spyder. Many people nowadays use VS Code, that is Visual Studio Code from Microsoft, to do Python programming. So if you'd like to do that, you can try that out as well. All right, so as I said, we're going to take a look at how to solve problems, first using top-down programming, and then a little bit of object-oriented programming. We're going to take a look at how to do computations, how to do relational tests, less than, greater than, equal to, how to do logical tests, true, false. We're going to take a look at character strings and how to analyze and manipulate those. And we'll take a look at Python's mechanisms for making decisions between alternatives and for defining loops to cause things to happen over and over and over again. Python has a built-in number of so-called collections, including lists, tuples, sets, and dictionaries. We will investigate all of those. And then there is a higher level. No, higher level is not correct. There is a specialized collection type for doing mathematical computations, array-oriented computations, called NumPy, which stands for Numerical Python. And we'll take a look at that thing. We'll also see how to define functions of our own and how to organize those into modules. Okay, so if you're not familiar with programming, a great deal of what I just said probably makes no sense at all, but it will make sense as we progress. Okay, now here is the Heinz College grading scale. This scale you should consider to be the worst case. If you score 97% on the final exam, you will get an A+. But frankly, I usually apply a more gentle grading scale myself because I am not a great judge of how difficult my exams are. So if I give a final exam that's very difficult and the top score in the entire class is 80%, that does not mean that the person who got the top score is going to get a B- on the exam. Whatever the top score is on the final exam, I will define that as being an A+. And then people with scores that are close to the highest score will also get A+, and then the curve will go down from there. So, as I say, this Heinz College grading scale, that's a worst case. And I usually apply a somewhat gentler scale. All right, well, I don't want to read this topical outline to you because we are going to go through it. All right, on a week-by-week basis. In terms of homeworks and quizzes, homework is always going to be due on Monday nights. There will be 6 homeworks due on Monday just before midnight, September 2nd, 9th, 16th, 23, and 30th. And then the final homework will be due on Monday, October 7th. The final exam will be available during a 24-hour period on Friday, October 11th. These quizzes, the weekly quizzes, will become available at the beginning of the week. So the week 1 quiz will become available immediately, but you must be finished with it by midnight Friday, September 6th. So that's 1 week from this coming Friday. And so that should give you ample time to take the quiz up to 5 times if necessary to get your A for the quiz. And then the subsequent quizzes have their own Friday deadlines. Homework is going to be due at 11:59 on Monday night each week. Only one member of each homework team should post a solution, and that solution should be put into a zip archive. Often your solution will just consist of a single file, but nevertheless I ask you to zip that file and post it. Sometimes your homeworks will consist of multiple files, and then you'll need to zip all of those files together and post them. You will lose points rapidly for late homework, so just be careful about that. Okay, now the remainder of this I think you can read through yourself, so there we are. All right, now, last thing. Anytime you have any question about anything, about the syllabus, about homework instructions, about grading, anything at all, do send me an email, and I will respond to you as quickly as I can. All right, so take care, and I hope you enjoy the course and benefit from it.